Hi there and welcome back. Today I've got a very quick video for you. This is not a demo. I know the channel is predominantly demos, but I thought I should cover off some kind of governance and conceptual kind of things as well. So I'm going to have a few very short videos just to explain a few things. The first one today is kind of what a data lake is, what it's kind of not. From a conceptual point of view, so all of this is often arguable as to what actually constitutes the lake. But hopefully you'll kind of see my reasoning when I'm saying this particular thing shouldn't fit from a governance perspective within what you call your data lake. It's entirely up to you what you call things, and it's entirely up to you where you put things. Later in the series, we'll discuss kind of how to split your data, where to store your data, how to back up and recover your data, and all of those kinds of cool subjects. But today, it's all about what is and is not within the bounds of what I consider a data lake. So I hope you enjoy the video, and if you do, please, as always, hit subscribe and hit that like button below. Thanks very much. So for this video, this diagram that's on the screen is pretty much what we're going to be talking about. As you can see, we've got the data lake in the middle here. So conceptually, I think everyone kind of understands that a data lake is just a bunch of data sitting somewhere. It doesn't necessarily have any structure or schema specifically. It's just a bunch of data sets. And you are free to define those data sets however you want to. You can put as much structure in them as you want to, and that kind of thing. But once we get into the more governance oriented side of things, it really starts to drive how you want to organize these things and where you want to put them, what you want to call things, and where you're drawing the boundaries of your data lake. So we've got the systems of record over there on the left, and this is the pretty standard kind of stuff where you've got your existing systems. A system of record is the owner of a piece of data. So this would be your CRM system, for instance. That might sit on-prem, it might sit in the cloud, it might be a software as a service offering from somewhere else. And quite often we'll just use something like Data Factory to ingest that data into the data lake. This is a second copy of that data. So you're no longer working on the live data, and we're free to do kind of analytics and cool stuff with it. The reason why we use a data lake these days is it's scalable outwards so that we can have many compute nodes working on the same data at the same time. The one where things get a bit confusing is IoT. So in a lot of IoT architectures, you'll see the data just gets dumped into the lake. And it's important to understand that, yes, the technology is the same, but the way that you think about that technology might not be. So one of the important architectural principles that I often talk about with customers is the data lake is not your system of record. And therefore, it doesn't need a lot of that governance necessarily that some other systems have got. So you don't necessarily need a DR where all of your data is copied because that data was derived from system of record data. IoT changes this because it is native to the cloud, and therefore the storage that you're using will be data lake type storage or blob storage. But the important thing there is it is a system of record. That's the only copy of the data. We didn't ingest it from somewhere. So it's important that you therefore back up this data. It could be important to you. It's important that you have a disaster recovery for it because it is a line of business system potentially. So if you've got factory machines that are pushing stuff into an IoT hub and you're taking actions based on that, it's important that that keeps running in a disaster. Whereas the analytics that come off of the back of it might not be quite so urgent to get back if you have a disaster. So that's where we get the two kind of stages there. So with IoT, we would have the IoT dumping into a storage account, which is conceptually not in the lake. Even though it's the same technology, it might be the same storage account, but we would do different things against that data. And then if we do analytics with it, we might take a copy of that. We would potentially treat that as our raw storage, but we might take a copy of that to do analytics on because we don't want to corrupt the original copy of the data in any way. And that gets to be quite important when you're actually working directly against a system of record. That's why on this diagram I've drawn IoT as a separate thing all on its own. The next one I'm going to talk about is data warehousing. So this is almost exclusively the first use case that comes up for when we're putting data lakes in with customers. And what we're doing is taking data from a system of record, copying it into what we often refer to as raw storage in the lake. Then we're going to do some processing of that data. We might clean it up. And then we're going to move that into a modeled version of the data, and then we're going to load it into a data warehouse. Now, that conceptually is all one thing, but it's quite important from a governance perspective, again, to separate out in your mind what the different components of that are. So you've got your system of record, you've got your data lake in the middle. The data lake is where we're going to house the raw storage and the processed storage to create the model. But we might have modeled data such that we have a complete data set of our customers. And that might be created from several source systems. It's quite likely that you'd have slightly differing customer records in different systems. Ideally, you'd have some kind of a master data management in your systems of record to deal with that, but quite often that's not the case. So within the data lake, we're going to consolidate those. We'll have a data set for customer data, one for product data, etc. And then we might build a data warehouse data set that links all of that stuff together with facts and dimensions and stuff like that. That will be stored primarily on storage when you first create it, and then loaded into the data warehouse. It's not necessary to do it that way. It's just how the kind of most efficient ways of working seem to have landed. But I like to think of the storage where we put that model before loading it into the data warehouse as separate to the lake. In my mind, that is part of the data warehousing. It's the same model. We might access the data directly on the storage account, but that is a sort of different action than data lake. We might start putting permissions against that data. Generally, in a data lake, you don't want very fine-grained permissions. So you should restrict who has access to the lake and how they access the lake rather than giving specific permissions against it. It's not a presentation layer. A data lake is just a store of data that you will then load into a presentation layer to do stuff with, usually through automated means. And then finally, we've got machine learning. This is almost exactly the same use case as data warehousing. So we will be taking some data from the lake, doing some machine learning stuff against it, and creating a model. Quite often we'll have a separate area of storage, an experimentation zone, just for the data scientists to be working, so that they're not working on the kind of primary copy in the lake. There's no chance of corrupting the data in the lake if you're not working directly against it. And also you don't have any issues with accidentally overloading the lake with traffic if you get your Python script wrong, for instance, and you just start reading every single record in a billion row data set. But there is nothing wrong with hitting directly the data lake data sources for machine learning purposes. It gets more complicated with permissions, so it's easier from a governance perspective to set up an automation to copy the training data set out of the data lake so that the data scientists don't have full access to the full data set. But this is why there are separate zones here. Conceptually, all of it could be considered your lake, and you could just specify that we're going to set permissions and we're going to have different areas in the lake and refer to it as the data lake. Personally, I prefer to refer to it as the data lake in the middle. I'm going to have an IoT system of record. I'm going to have my legacy systems of record, and all of the current systems that run the business. I'm going to have a data warehousing area, or probably actually in reality, we're going to have 20 data warehousing areas for different purposes. We might have a sales data warehouse and an HR data warehouse, that kind of stuff, and a separate machine learning area. And this frees me up to put in different permissions, different systems, different ways of managing that data, different backup strategies, different performance dimensions to the system. And then I'm not trying to make one system that's got lots of different things in it. I'm trying to make several systems that each have one specific purpose, and we can really focus on that. So hopefully that explains my thinking there. In the future, we'll go into how to actually organize data on the data lake, what I consider a data set, and how we do governance against those things. So hopefully you enjoyed that. It was a very quick explanation of kind of what a data lake is. Join us next time for a discussion about data classification in terms of production or test and those kinds of environmental questions. Again, please hit the subscribe button and hit the like button. It really helps the channel out, and I will see you next time. Thanks.